Hello, I'm Michael Bondi from Boston Scientific.
And I'm Taylor Passafero from Boston Scientific.
I am a mechanical engineer in the Design Equipment Engineering department, which means I get to design all the equipment that builds our devices.
And I'm a research and development engineer. I design the new products that Boston Scientific makes.
And we're here to talk to you about vacuums and pressure today. Now, we're going to start off with a vacuum. What you see before you is a vacuum, just like what your parents have at home. And it creates a negative pressure with the chamber it's around. We've got our pipe of the vacuum hooked up to this chamber, which we're going to put our objects in today.
The object that we're going to put in there right now is a balloon. Now, this balloon looks empty, but it's not actually empty. There's a little bit of air in there. And that's going to be important when we put it in here. We're going to turn on the pump.
And so now what we're doing with this is we're taking all the air that's in the chamber and we're pulling it out, which means that the pressure inside decreases. Now as the pressure inside the chamber decreases,
the pressure inside the balloon has not changed, which means that relative to the pressure inside the chamber, it's going to increase. And that's why the balloon is expanding. That little bit of air that was inside of that balloon is getting bigger and bigger and bigger because there's no pressure on the outside to actually push it. There's a zero pressure inside this chamber.
So now we've got a balloon that is up to the size that it's at. We're going to stop the machine, open it up,
and the balloon goes right back to the way it was because now we have all of this air out here pressing down on this, and the little bit of air inside this goes right back to the way it was.
All right, the next activity that we're going to show you is we've got a ping pong ball inside a tube with both ends capped off. So the air can't leave either end when I drop this ping pong ball. So now my question for you is if I drop both of these ping pong balls at the same time, which one will fall fastest? Well, it was definitely the one that was outside of the tube. Taylor, why is that?
Well, the reason why that is has to do with the diameter of this ping pong ball and the diameter of this tube. Now notice that, as Bondi said, this ping pong ball is just barely big enough to fit inside this tube, which means that as it falls, that air that's below it has to go somewhere. Can't go out the bottom, so it's going to try to flow around this ping pong ball. The problem is that there's just not a lot of space around this ping pong ball for the air to rush past, and therefore it's going to fall slower. That's going to create a bit of a vacuum up here and a bit of positive pressure down here. And as this falls, that vacuum and that positive pressure is going to travel with the ping pong ball.
All right, we're going to do the last of our demos today, and this is the best one of them all. It's the air cannon. We're going to combine everything that we've just talked about into one demo. So what we've done is we've sealed off the tube with both ends with packaging tape, just like we did with the tube on the table. We've got a ping pong ball in the center, and we're now hooking a line up to this tube to our vacuum, which is going to create a vacuum inside the tube. All right, so now we're going to turn on the vacuum pump. And as the vacuum pump goes on, Taylor, do you want to explain to us what's going on?
Well, all the air is being evacuated from this chamber, and that's creating zero pressure inside this thing. Now, there's going to be a very big difference between this tube and this tube. Now, remember when we told you before, the ping pong ball inside this tube has to have air rush around it in order to move anywhere. So, if we were to tilt both of these and see which tube goes faster, this one goes much faster. The reason for that is that there's no air in this tube. It's all been evacuated. The air doesn't have to flow around the ping pong ball. It doesn't have the same problems that it does like in this smaller tube. But that also creates another interesting situation because since this is a vacuum, if we poke a hole in the end of one of these packing tapes, it's going to create a huge amount of positive pressure at one end. All of this atmosphere around us is going to force its way into this tube and send this ping pong ball rocketing out the other side.
Should we do it?
Let's do it.
All right. So again, Taylor is going to poke the far end of this tube with the scissors, which is going to break that packing tape, letting air come in. Are you ready, Taylor?
I'm ready. In 3, 2, 1.
And that is the air cannon.
So all this pressure stuff is a lot of fun, but it actually has a lot of real-world applications to what we do here at Boston Scientific. So this is one of our products that we make here, and this is called a balloon catheter. And just like its name says, this has a tiny, tiny little balloon right on the very end of here. Except this is a special balloon. It can take a lot higher pressures than your standard party balloon, and the way we blow it up isn't with our breath, it's with a special device. So what's going to happen is Michael is going to push on this, and it's going to inflate this balloon, just like that. And as I press on this, you can see that the air inside this is, well, it's not going anywhere. We've inflated this balloon. And we want to deflate it. You can pull it back, and there we go. It's compressing back down. And this is the way that doctors and physicians open up arteries inside of patients in a non-invasive way to restore blood flow.